This is section 1.5, rewriting equations and formulas. So rewriting equations, we're still going to have an equation, we're still going to be solving for a variable, but now there's going to be more than one variable in that equation. So you might have an x and a y. Your answer will not be a number. This is important to remember, that it should have at least one variable in it. And then some vocab, a literal equation is just an equation with two or more variables. So let's do an example. So we want to solve 3y plus 4x equals 9 for y. So what I would recommend doing first is either circling or highlighting or marking in some way what you're going to what you're trying to get by itself, which in this case is y. Then start getting rid of moving things to the other side. So in this case, the 4x is farthest away from the y, so I'm going to get rid of it by subtracting 4x from both sides. So 3y equals, you can either write it as 9 minus 4x, or I like to write it negative 4x plus 9. Either way is fine. And then we're still looking for that y, which means now we have to get rid of the 3, so I'm going to divide both sides by 3. Super important that on the right side we divide everything by 3. This will go away. So we are left with y equals negative 4x plus 9 all over 3. That's acceptable, but there's also another acceptable answer, which is y equals negative 4 thirds x plus 3. So what I did there is I did this fraction and this fraction. So negative 4x over 3 becomes negative 4 thirds x, and then 9 over 3 becomes 3. Notice that either answer is acceptable. All right, let's try another one here. All right, so we have y equals 3x plus 5xz. And we're solving for x, so I'm going to highlight anywhere I see an x. Notice that what is different about this one is now there are two terms with x in it. So we got to figure out how to get that with one. We can't combine the 3x and 5xz because this second term has a z in it, so that makes them different, so they can't go together. So what we're going to do is we're going to leave the y equals, what we're doing is we're going to undistribute. So we're going to undo our rainbow. So since they both have an x, I'm going to take that x out in front. And if we take x out of 3x, we're left with 3. And we take x out of 5xz, we're just left with 5z. So now our x is pretty isolated. So let's get rid of the 3 plus 5z. We do that by division. So we divide by the quantity 3 plus 5z on both sides. So we get y over 3 plus 5z equals x. And we're done. All right, let's practice one like that again and move on to the next one. All right, so we have 3 plus 5x minus kx equals y. And we're going for x again, so I'm going to highlight my x's. Notice again we have multiple terms with an x in it, but we also have that 3 that doesn't have an x. So what I'm going to do is I'm going to get rid of that 3 first because I only want terms with x's left on the left side. So I'm going to subtract 3 from both sides. So 5x minus kx equals y minus 3. All right, we're still looking to get that x by itself. So let's undo the distributive property by taking that x out, and we're left with 5 minus k. Still trying to get x by itself. So let's divide both sides by 5 minus k. So we get x equals y minus 3 all over 5 minus k. Notice that your answers aren't necessarily going to be very simple. Okay, we still have variables, and now we've got some division and stuff going on. But this can be helpful when we have real world equations. So for example, in science, we a lot of times will convert from Fahrenheit to Celsius. We can use one equation. So if you have the equation to get from Fahrenheit to Celsius, but you need to go the other way, you can solve the Fahrenheit equation for Celsius. So now you have the equation to go from Celsius or Fahrenheit to Celsius. All right, let's try a word problem here. So you own a rectangular lot that is 500 feet deep. It has an area of 100,000 square feet, and to pay for a new water system, you are assessed $5.50 per foot of lot frontage. So first of all, we want to find the frontage of our lot. So there are two ways we can do this. Okay, we're dealing with area, and we have a rectangle. So we know that the area of a rectangle, so area equals length times width. We can either plug in what we have and solve for what we don't have, but let's practice our skill that we're working on today. So what we need to do is we need to find right here this frontage, which is going to be the same as our width. So we want to solve for W. So in order to solve this for W, we're going to divide by our length. So we get our area divided by our length gives us our width, which is our frontage. We know that the area is 100,000, and we know that the length is 500. Now we can just plug into our calculator 100,000 divided by 500, and we get 200 feet. Make sure when it's a word problem that you're labeling it. So the frontage of the lot is 200 feet. How much are you assessed for the new water system? Okay. So to pay for a new water system, you're assessed $5.50 per foot of lot frontage. So it's $5.50 per foot for those 200 feet. So our cost is equal to $5.50 times 200, which is our frontage. Just go to your calculator, $5.50 times 200, and we get a cost of $1,100. And like I was talking about before, formulas to know. You don't necessarily have to memorize these, but these are ones that are used pretty commonly. Whoops. So the temperature, where C is Celsius and F is Fahrenheit. So Celsius equals 5/9 times the quantity Fahrenheit minus 32. Simple interest. So for a bank, when you go deposit money, you get interest. So the interest is equal to the principal, P, which is what you put in originally, times R, which is the interest rate as a decimal, times T, which is the time in years. And then the distance formula. Distance equals rate times time. So feel free to refer back to this for those three formulas that you might need on your homework or in the future, but you do not have to